Bismillah ar-Rahman ar-Rahim. Alhamdulillah wa salatu wa salam ala Rasulullah Muhammad bin Abdullah wa ala alihi wa sahabihi wa mawala wa ba'd. Good afternoon, my listeners, my viewers, and my subscribers. Welcome to this channel, Swap Academic Online Class. Today we are going to be seeing something on what? On problems, practice problems regarding fundamental quantities and what? That of what? Derived quantities. So that's what we are going to be looking into. And this today class will be of two episodes. Episode 1 will be a prepared question. This question that you are seeing on the board is a prepared what? Prepared question on what? By Swap Academic Online Class. So we are going to see little prepared question from Swap Academic Online Class. Then we will see a practice question under jamb series. I mean a related and a review past question on what? Jamb activities. Inshallah, that will be 2 episodes. Let's quickly look into this. I told you the video we dropped earlier, go and check it to know what are the fundamental quantities and what are the derived quantities. How do we differentiate them? Now this question, let's read. What is the correct SI unit for heat capacity? What is the what? Correct SI unit. System International Units. For heat capacity from the following what? Options below. We have I, which is 1. We have 2. We have 3. And we have 4. Is it Kelvin per Joule? Or Joule per Kelvin? Or none? Or Joule seconds per what? Celsius? How do we do that? A, these are the options. We have to pick options from this. Now, how do we do that? Know that this particular, let's check this particular topic. This particular heat capacity fall on what? Heat energy in physics. Heat energy and measurement. So, when you will see the formula that is talking about heat capacity and specific heat capacity. There is difference between heat capacity and there is difference between specific what? Heat capacity. Because of the time factor, let's go straight to this question. In order to know the formula, because before we can pick any options there, we have to know the formula. Then from that formula, we derive the what? Their SI unit. And we pick the correct what? Options from this. All we need to know is that heat capacity. Heat capacity means what? Means MC. It means what? MC. MC. This is heat capacity. We still talk on specific heat capacity. And the formula for that is that, what relates that together is as a result of the heat equals to M, that is the mass, and the C, then change in what? Change in temperature. This is the heat capacity, this is the heat quantity, this is the mass, this is the what? Specific heat, and this is the what? Change in temperature. That means T2 minus what? T1. Then what are we looking for here? I have told you that this heat capacity, it is what? It is the combination of M and C. That means this is M and C, which is representing as what? Heat capacity. We make it the what? The subject of the formula. This is the general equation. Make MC the subject of the formula. That is what the question is. The question is heat capacity, and MC is the heat capacity here. Divide through by what? Change in theta, which is change in temperature. Divide these two by what? Change in temperature. Divide both sides by change in temperature in order to make what? The subject of the formula. MC, which is known as the heat capacity. Now this settles this. What are we left with? We are left with what? MC equals to what? Q. All upon what? Change in what? Change in T. Are we? Now this is the formula for calculating for calculating heat capacity. Now, we are not really calculating. We have to derive the what? SI unit. Correct one. Now, note that Q, it is electric charge. And anything charge, which is known as also the heat. Anything heat. Q stands as a heat. Anything heat, it is denoted as what? As Joule. Joule. The same SI unit with what? Energy. It is denoted as what? Joule. The same SI unit with what? Energy. All together. And in some cases, in physics as well, we still use Q as electric what? Electric charge, which we use what? Coulombs, right? Now all we need to do now is that this is Q. Q now, based on this topic, Q is known as heat, and it is denoted as anything heat, it is denoted as joule. Now if you are having joule, this is par, put par, this is par. This is theta. This theta in physics we call this temperature. Now temperature, the standard SI unit for temperature is what? The standard SI unit for temperature is what? It is Kelvin. Even if you are given in degrees Celsius, I have to change it to what? To Kelvin. Now which will now be what? K. So joule per Kelvin, or they can put it like this: joule per Kelvin. It's still the same thing. This part they will put it on top, or they should write it like this. It's still the same thing. So now let's see the correct options from this. We have I to be Kelvin per joule. We have 2 to be joule per Kelvin. We have 3 to be none, and we have this to be joule seconds per degree Celsius. So what would that be? Now let's see the correct options there. A, is it A, which is number 1? No. K, J comes before K. J, K. So this one is not the correct answer. A is not the one. B, joule per Kelvin. It is check, joule per Kelvin. Now that means this is the correct option. So the answer for this particular question is what? The heat capacity, the SI unit is what? Joule per Kelvin. Are we together? Joule per Kelvin. They can still write it like this. It's still the same thing. Joule per Kelvin.